Hello everyone. Today I'll be showing you my 3x2 memory circuit from the TEJ4M0 computer engineering course. This circuit is designed to save and output 4 numbers from 0 to 3 in binary. Right now you're seeing my completed circuit. It uses one 7404 inverter IC chip, one 7432 OR gate IC, 3 7474 commercial D flip-flop chips, and 5 7408 AND gate ICs. It also uses 5 single-pole double-throw switches to operate the circuit based on the following schematic. In reality, it's fairly simple. If you compare between the circuit in real life and the schematic, we see the data switches, which are for you to save your number, the address leads or switches, which are used to select the memory cell which data is saved into, the read-write switch, which is used to change between the modes of reading the data and writing the data from and into the memory cells. The circuit is in read mode when the switch is closed, and it is in write mode when it is open. The LEDs, which are used to represent the number saved in binary, where the green LED represents the carry and the red LED as the first digit. Now, looking at the circuit, the most important part is actually the read-write switch. When the switch is closed, the current flows through the switch. It causes the clock input of the commercial D flip-flop to be low, causing the flip-flops to output their saved value to the respective AND gates and be displayed with LEDs. The preset and clear inputs must be connected to the positive terminal to make the circuit asynchronous, meaning independent from the clock. When the switch is open, current flows through the clock input of the flip-flops, and since our commercial D flip-flops are positively triggered, or positively edge triggered, it stores the values of D0 and D1 to the flip-flop, indicated by the address leads. Now, let's see how address leads work. There are 3 locations to save the data, location 1, 2, and 3. To save data in a specific location, you must represent 1, 2, and 3 in binary with the switches. A1 is the carry, and A0 is the first digit. So, 0, 1 is the data location 1, 1, 0 is data location 2, and 1, 1 is data location 3. 0, 0 doesn't work in this case, since there is no memory cell associated with that input. Whatever the value of address leads that you are using means that you're using that memory cell, whether it is memory cell 1, 2, or 3. Now, the equally important but important part of the circuit is the data switches. They indicate the data to be saved into the memory cells. However, it must be saved in binary. D1 represents the carry value of the 2-bit binary number, and D0 represents the first digit. Similar to the address leads, 0, 0 represents 0, 0, 1 represents 1, 1, 0 represents 2, and 1, 1 represents 3. So, let's combine all the information about the switches so we understand how to operate the circuit. First, we must set the correct address leads so that the data saves to the correct location. Then, we set up the data that we wish to save. Finally, we set the circuit to write mode, and the number is now saved into the indicated memory cell. For example, let's say we want to save the number 3 into the 3rd memory cell. We set both address leads to 1, hence 1, 1 is 3 in binary. Then, we set the data switches to positive. Once again, because 1, 1 is 3 in binary. Finally, we set the circuit into write mode, and now 3 is saved into memory cell 3. If we wish to see what was saved, we set the circuit into read mode. In read mode, D0 and D1 switches are irrelevant. And also, you can see what's saved in each memory cell by navigating through the address leads. Currently, there is only 1, 1 or 0, 0 saved in the other address leads. But you know what? Let's try the circuit out in real life. Let's try saving the number 3 into the 3rd memory cell on the real circuit. We first must turn on the circuit, and then set address leads to 1, 1. Then, we set the data switches to 3, once again, 1, 1. Now, to save it into the memory cell, we have to set the circuit into write mode. It is now saved into this memory slot 3. Now we set it back to read mode. It now shows us what is in memory slot 3, which is 1, 1, being 3. And there we go, that's how we save a number. So, to save a number into different slots, we change the address leads and repeat the process. Remember, we can only save to 3 spots. 1, 2, and 3 being 0, 1, 1, 0, and 1, 1. Thanks for watching, and I hope you guys learned a lot from my video.